Welcome to WebGoat's A1 Missing Function Level Access Control. In this module, our goal is to find data in the page's HTML that the developers tried to hide and use what we discover to gain access to data we weren't meant to have access to. As always, before we get into the module, I'm going to briefly touch on some core technologies used. The first thing I want to review is the basic concepts of HTML that are related to this module. Crash course, elements in HTML can have child elements such as a list containing list items. Elements can have direct styling or can have a class or ID attribute, which then can be targeted in a CSS file. You can use CSS styling to hide an element from what's known as the document object model, which is essentially the container that hosts everything you see on a website's page. Second, let's briefly overview what a JSON object is. A JSON object is an object surrounded by curly braces that contains a number of key value pairs. A good example of this is an object that hosts user data with a key for username, password, and role, and values for each of these keys set accordingly. What you see here is the actual syntax of a JSON object. These objects are specifically useful for passing data in a POST request between a client and a server. Note that if you need a refresher on HTTP methods, you can refer back to the insecure direct object references earlier on this channel, or you can click the card to go directly to that video on the top right. Just ensure that you understand the difference between HTTP GET and POST methods, as you will need this knowledge later in the module. Now that we know these two things, let's get into the module. After loading into the first section, we can see that the developers at this website tried to hide some elements in the HTML or the CSS that contain two elements that we're not supposed to have access to. So let's inspect the section below by right-clicking and clicking Inspect. Note here that if you click Inspect and it pulls up something like this, click Inspect again and it should pull up the actual element. Loading into the source HTML, we can see three list item elements, all three of which have the drop-down class attribute, and one of them has the hidden menu item attribute. So let's open this hidden menu item and see what it has inside. After opening, you can see that it contains two elements, an anchor element and an unordered list element. First, we can investigate the anchor, which after opening, we can see just contains the title of the drop-down button that's hidden in the menu. So now we can move on to the unordered list and see what that has in store. And here we can see that it has three items that we can't actually see on the menu items above: users, users, and config. These are the two values that it's looking for, as we have two users, so we can just say users once and then config. If this section seems simple, that's because it is, and it's here to show you how to access hidden data in an HTML file, and it also serves the purpose of providing the endpoints that we'll be using later in the module. So now moving on to section 2, we can see that we're trying to gather the password hash for the account Jerry. Let's first start by going to our Burp Suite intercept again and turning on intercept. Then by going back to WebGoat and hitting submit, and then going back to Burp Suite intercept and forwarding the request until we find the endpoint we're looking for. In this case, it's going to be the user-hash endpoint. Now let's refer back to the three endpoints we found in the previous question. We'll start with the first one at the user's endpoint, and then send the request as is. We can see it returning an HTTP status of 415, which means an unsupported media type. This means that we need to change the content time sent from our request. So now in our request, change it from application/xwww form URL encoded to application/JSON. Now let's send the request again and see what it returns. We can see here that it's returning an HTTP status of 400, and that the error code is telling us that it was expecting a JSON object. This is because we're sending a POST request which expects a JSON object in the body. So let's change the request method from POST to GET. Let's also make sure to add a value to the user hash parameter, just so we don't receive any null errors. After sending this GET request, you can see the three users already in the database along with their user hashes. Copy Jerry's user hash and paste it in the submit box back in WebGoat. Now we understand the endpoints, how they work, and how to get the user hash of a user. So let's move on to the final section. Unfortunately, at the time of recording, the endpoint required to solve this section is non-existent within WebGoat. However, not all hope is lost, because we do have access to the source code of WebGoat. So here's the method that processes our submission. We can see that it's grabbing Jerry's user, and then comparing the hash that we submit with the hash of his password. In the missing function ac.java file, we can see the two hashes for sections 2 and 3. And then going over to the display user.java file, we can see how they use these values to encrypt a password. All we have to do now is grab Jerry's credentials from the SQL file, and then we can recreate the encryption process in our own Java file. So first, let's import the required packages, and then create string variables for the password, username, weak salt, and strong salt. Next, we can grab the SHA-256 algorithm and store it in a variable, and then create our salted string by concatenating the password, password salt, and username. Just note that here, we're first going to try this with the weak salt so that we can compare the value we get with the value we already know from the second section. Now we can use our SHA-256 to process our salted string into a hash variable, which is going to be an array of bytes. All that's left to do is convert this into a base 64 string and print out the result. We can see here that the value we're getting for the weak salt matches the value from the second section. So now let's replace the weak salt in our string to the strong salt. And then we can rerun the algorithm and we have our answer. Once you have this new hash, copy and paste it back into WebGoat and you've successfully completed this module. Congratulations, you've learned how to exploit missing function level access control. Thank you for watching.